Enterprise application development on Google Cloud requires a precise baseline, velocity to deliver, resilience to survive, and strategic clarity to scale. This means deploying standardized enterprise developer platforms to accelerate your release cycles. It requires fault-tolerant architectures to defend against outages, and it relies on architecture decision records to enforce strict governance across every deployment. Pushing for speed without governance creates unmanaged risk, while building heavy defenses without developer platforms stalls innovation. Integrating all three elements enables high-frequency, highly secure deployments at an enterprise scale. To decouple application logic from underlying infrastructure management, engineering teams use the Enterprise Application Blueprint. This deploys an internal platform utilizing GKE fleets, giving developers isolated, ready-to-use runtime environments. This diagram shows the automated delivery pipeline. A single code commit triggers a build. That immutable container is pushed into artifact registry and then systematically deployed across development, staging, and production tiers. Notice the strict separation of operational duties here. Application developers own the code and build phases. Site reliability engineers take over at production, managing capacity, service level objectives, and incident response. Defining these boundaries in the platform eliminates workflow bottlenecks. Engineering groups can push automated releases simultaneously without compromising the organization's governance standards. But delivery speed is useless if the application goes offline. High-frequency deployments must be shielded by fault-tolerant architectures that systematically eliminate single points of failure. Look at this matrix comparing deployment archetypes. Moving from zonal to regional to multi-regional and global configurations directly reduces the risk of downtime by increasing the geographic distribution of your resources. Zooming into an active-active multi-regional setup, the architecture relies on two identical geographic regions. A global cloud load balancer sits at the entry point, distributing incoming traffic across regional managed instance groups in both locations simultaneously. If one single region experiences an unexpected outage, the load balancer instantly reroutes all incoming requests to the healthy region. This active-active design absorbs massive traffic spikes and survives localized failures automatically, ensuring continuous user access and protecting revenue. To guarantee these architectures remain secure across thousands of deployments, technical choices must be codified. This is the exact function of architecture decision records, or ADRs. This table illustrates standard ADRs in practice. The records mandate GKE for managed containers to ensure portability, require gateway APIs for declarative ingress routing, and enforce binary authorization to guarantee code provenance before any container reaches production. Embedding these rules into the developer platform transforms abstract security policies into an auditable, repeatable system. It actively prevents configuration drift before code is ever deployed. Mastering the cloud environment requires building all of your applications as secure, highly scalable assets that are designed for continuous operation. Integrating automated developer platforms, active-active resilience patterns, and strict architectural records creates a predictable, auditable foundation for your enterprise application portfolio.